Let's do an example from section 8-6 where we're doing a hypothesis test for a standard deviation. We have our requirements that the sample has to be simple and random, and the population has to come from a normal distribution, or has to be normally distributed. We will be using a chi-square distribution for this problem, and this is our formula for our test statistic. The chi-squared critical values can be found in table A4, and the degrees of freedom would be n minus 1. So here's our problem. It's asking us to check, well, it says the golfing association requires the standard deviation of the diameter of golf ball has to be less than 0.006 inch. Determine whether the ball conforms to this requirement at the 0.01 level. So this is a version of a quality control. So imagine if you're producing all these golf balls, if you have a lot of variation, then that's not good. So what they want to do is they want to keep their standard deviation to be as small as possible, and I guess 0.006 inches their requirement for that. Alright, let's set up our hypothesis test for this problem. Our claim, we want our claim to be that the standard deviation of the diameter of golf ball should be less than that. So let's get that written. The diameter inch, and we want to write that in symbols. So the standard deviation, we use sigma for that, less than, and then that number. So let me jump ahead, and because this is a strictly less than sign, this is going to go into our alternative hypothesis. So sigma less than 0.006 inch. And so what we can do is, for our null hypothesis, we can say equal to, or we can say greater than or equal to. Depends on how we want to set it up. So let's use equal to for this case. And so this is our statement, and let's just put a little note for ourselves that this alternative hypothesis is our claim. Next thing we're looking for is the significance level, 0.01. Now we are interested in using this test statistic, but we have data given to us. So what we're going to do is we're going to need to punch all that information in our calculator and then compute what we need. And in this case, we don't need x bar, if you notice, but we do need s. Sigma is 0.006. That's the null hypothesis that we're going to use, and our sample size n is going to be whatever our sample size is. So let's do that information is already typed up. Let's do a quick one var stats on L1, and then we're going to make a note that our standard deviation, and remember to use Sx, not sigma, standard deviation is 0.00287. The more decimal places, the better. Our sample size is 12. So now we're all set, and given that our sample size is 12, we should also make a note that our degrees of freedom would be 12 minus 1. And so this is going to help us work out our critical values. So let us find our critical value. For our critical value, we need to use table A4. But let's first begin marking this up because we're going to get some information here. This is going to be a one-tail test to the left, and then we're going to have an area here of alpha, which is 0.01. Now the chi-square distribution is going to want us to look at the area to the right of the critical value. So if this is 0.01, then the area to the right of the critical value is 0.99. With the degrees of freedom of 11, our critical value, degrees of freedom 11 and 0.99, so that would be 3.053. This is our critical value. Now we have our critical value, but we still want our chi-square. So our chi-square is going to equal to, looks like we have an n minus 1. So n minus 1, we got that to be 11, and we want to multiply by our s, 0.00287, and we want to square that. And then we want to divide by, let's just put divide by here. And we were dividing by sigma, 0.006, and then we're going to square that as well. So let's just punch this in our calculator. We have 11 times 0.00287, square that, and then we'll divide by, and then we have 0.006, and then square that again. So we got 2.51 for our critical value, or for our test statistic. 2.516, let's call it 517. Now 2.517 falls in the critical region. So what we can say is since our chi-square which is equal to 2.517 falls in the critical region, we reject the null hypothesis. So in rejecting the null hypothesis, we come up with our conclusion, and our conclusion is again based on that flowchart. Did our original claim contain a condition of equality? The answer is no. Did we reject the null hypothesis? The answer is yes. So we're looking at this third block over here. It looks like our sample data is going to support the claim. and the claim that I'll just copy and paste exactly what it says in the claim, that the standard deviation of diameters of golf ball is less than 0.006 inches. So it looks like we have a good batch of golf balls, and our quality control was checked out, and it looks like we're good to go. So let's see what kind of question they have in the homework. Did the golf balls meet the requirement? So it looks like yes, it met the requirement. Our test statistic was in the critical region that made us reject the claim, but the claim was the opposite of the alternative hypothesis. So let's choose D, yes, because the test statistic is in the critical region. Okay, so that looks good.